Hello, my name is David Mills, and on behalf of Oracle University and all the folks that make Oracle integration possible, it is my pleasure to welcome you to this learning path towards becoming a certified OCI application integration professional. In this training, we've created some excellent video content that will guide you through each topic area, along with other resources to help you learn and achieve this certification. Since this learning path provides the fundamental training for Oracle Integration Cloud, obviously anyone interested in OIC is welcome, but if you're a software developer, integration specialist, cloud architect, or a system integrator, you certainly are in the target audience for this course. Ideally, any IT professional that has a basic understanding of integration fundamentals and are responsible for integrating cloud-to-cloud applications as well as cloud to on-premises use cases will benefit from this training. So let's break down the content you'll encounter along the way in this learning path. Application integration on Oracle Cloud is the main course, which includes recorded lectures and demos organized into 10 modules. You'll start with this introduction module covering a high-level look at OIC architecture and components, along with the basics of getting started with integrations. Next, it's time to take a closer look at OIC adapters, their functionality, and how adapter connection resources are defined. Then in Module 3, you'll learn how to configure these connections to be used as an integration trigger or to invoke an external system or application. In the data transformation module, you'll learn all about the OIC map editor as well as how to use OIC lookups. Module 5 covers how to use and configure various integration actions to facilitate the logic within your integration flows. In the file processing module, among other related topics, you'll learn about using the FTP and file adapters, as well as the operations of the stage file action. The next module focuses on how to use global and scope level fault handlers, as well as some error handling best practices in your integration flow design. Module 8 could have instead been entitled Miscellaneous, because here's where you'll learn about a variety of other topics. For example, creating schedule or event pattern integrations, leveraging the B2B feature, or troubleshooting with integration observability features. Next, we've organized the topics that are typically handled by OIC service administrators, such as provisioning an OIC instance or installing a connectivity agent, as just 2 examples. And finally, in Module 10, we've recorded demos of various integration implementations, several of which are available as pre-built solutions we call accelerators. In addition to the video lessons and demos, at the end of each of those 10 modules, we provide skill check questions to test your knowledge and solidify your understanding of the topics covered. Next, after you've completed the course content, you'll want to request an Oracle University lab environment so that you can do the hands-on practices covering these topic areas and more that include everything from creating integrations from scratch to cloning pre-built integrations that you can further customize. Each exercise provides a scenario overview and includes step-by-step instructions for completing each configuration task. Additionally, I have recorded videos that provide a full end-to-end demonstration of all 11 labs, which includes 62 practices. At any point in time, if you have a specific question about the course material or need extra help, fill out our Ask the Instructor form. Our goal is to get back to you as soon as possible with personalized support. We also want you to get the most out of your learning experience, which is why we've created this community space where you can connect with other learners and subject matter experts. If you have any questions or want to start a discussion on a particular topic, this is the place to do it. So don't be shy, join the OU community today and start collaborating with your fellow learners. We can't wait to see what you'll bring to the table. Of course, we here at Oracle University are continuously building and delivering training, always integrating your feedback and monitoring user analytics. So please feel free to rate this course and leave specific contents with what was helpful and what wasn't. We're constantly tweaking our approach so that we can better help our learners achieve their goals. Back to the learning path. Now, at this point, you should be ready to take the certification exam. However, to help you prepare, I've recorded 4 videos to create this short preparation course that reviews the exam topics and walks you through some test-taking strategies by looking at some sample test questions. Of course, you'll want to take the practice exam we provide prior to registering for the actual online certification exam to complete the learning path and be fully prepared. And finally, I'll acknowledge that this is a rather lengthy course, so here's some tips for increasing retention and giving you the best chance of success. We suggest that you take notes on topics based on your existing knowledge and experience, and remember, you can always follow along using the transcript tab and revisit anything you didn't fully understand. Even take a few extra minutes to read the relevant OIC documentation online to help provide more details when needed. Secondly, try to schedule breaks as often as possible and move around. Don't stay stationary in front of your computer for too long. Also, make time to work through all the hands-on lab practices in that OU environment if you can, or if you don't have a lab subscription, at the very least watch all the lab solution demo videos to see how it works. Remember to not only complete the skill checks provided at the end of each module, but go back and review all those questions again to help refresh your memory. And be sure to complete the exam preparation course, then take the practice exam as many times as you need so that you can eventually get 100% of them correct. At that point, you should be ready. So yes, this is an extensive learning path and certification, so take your time learning at your own pace. I hope that you're excited to learn more about Oracle integration. Let's get started. Welcome. Let's get this training started with an overview of the complete Oracle Integration Cloud environment. OIC 3 includes several features. You can design integrations to monitor and manage connections between your applications, selecting from a portfolio of pre-built adapters and recipes to connect with both Oracle and third-party applications. You can also create process applications to automate and manage your business workflows, whether they be structured or dynamic processes. The Visual Builder feature is an integrated development environment that allows you to create and deploy custom web and mobile applications. You can store and retrieve files in Oracle integration using the embedded secure FTP compliant file server. And this feature allows you to use B2B e-commerce to extend integrations to reach trading partners. Of course, since the predominant OIC feature is integrations, that is indeed the primary scope of this learning path, but you'll also see some videos and demos that include the file server and show using the B2B feature with integrations as well. However, since both Visual Builder and Process Automation have their own separate Oracle University training courses, those two features will not be part of this learning path, nor will they be on any application integration certification exam. All exam questions will focus on the integrations feature. However, since this is an overview lesson for all of OIC, we'll briefly talk about each of these, starting with process automation. Now, to use this feature, it must first be enabled after the OIC instance has been provisioned, because as you can see, it is not enabled by default. Now, once enabled, it appears in the OIC Service Console menu as process, and when a developer clicks the link, it will take them to this new web page where they can now get started on their first process application. Low code means that developers and business experts can collaborate to create processes using a simple visual interface. You drag and drop from a visual palette to include pre-built integrations, decision services, and human task configurations. This is an extensive product on its own where you can design and adapt workflows efficiently with visual process modeling tools, primarily focusing on human-centric business processes. Another capability is to automate decision-making with customizable business rules and logic. And although human-centric integration is the focus, you can also seamlessly integrate with external systems for data exchange and collaboration. To streamline data capture and input, you can create user-friendly web forms, and it's important to be able to track tasks, assignments, and approvals in real time for enhanced efficiency and accountability. Process automation development and runtime management environments enable you to perform iterative process automation development using Designer to create applications and their components, and Workspace to test, run, monitor, and administer applications. Next, the Visual Builder feature is also an extra app that must first be enabled. Then when you click on this link in the OIC Service Console menu, it launches the Visual Builder web app, where you can now start building web or mobile applications without any additional setup. When you click to create a new application, it opens on the welcome page in the Designer. Shown here is the what you see is what you get page Designer, where you drag and drop UI components and visually create your pages. A Visual Builder provides simple but powerful visual development tools that help you quickly design your app with UI components and customizing their attributes to define behavior. Now, while these tools lend themselves to low-code developers, experienced developers can just as easily access the underlying source code, even extend it using standard HTML5, JavaScript, and CSS techniques for more complex needs. You access your app's data through REST-based services, where you create reusable business objects to implement application logic and store data, which can then be managed through REST endpoints that Visual Builder generates for you. Or you can pick data objects exposed by Oracle SaaS applications or OIC integrations in an integrated catalog of REST services. You can also access data from any external REST service with just a few clicks. This is a complete development tool as well as a hosting platform, which means you can manage your application's lifecycle right from development to test and final publishing, where version management and data migration are built into the app's lifecycle, making it easier for you to stage and publish your app and manage its data in every phase. An administrator must enable file server before an organization can start using it with their OIC instance, and enabling it is a one-time action in the OCI console. Then back in the Oracle Integration Service console, administrators can navigate to the settings page to monitor the overall health of file server and to change its main settings if needed. Developers can then design integrations that process files Developers can then design integrations that process files in the embedded file server, where you have two options for connecting to it from an integration flow, the FTP adapter, and the file server action. This OIC feature eliminates the cost and operational expenses associated with hosting and maintaining a separate secure FTP server either in the cloud or on premises. You can also give your vendors or partners access to your OIC instance file server where they can upload or download files using their secure FTP client software. B2B for Oracle integration provides support for business-to-business e-commerce, allowing you to communicate with trading partners by sending and receiving data from your integration flows. Now, from this menu, in addition to configuring the host profile for your organization, you can define one or more trading partners, along with all the schemas and document types you'll be exchanging, such as purchase orders or product specifications, using standard EDI formats. B2B represents a collective set of features inside OIC to support processing to include a trading partner management interface, a schema and document editor for customization, a specialized B2B tracking user interface for viewing messages exchanged with trading partners, and adapters to support B2B protocols such as AS2, Rosetta Net, and FTP, of course, and actions you configure within your integrations for EDI processing. Integrations deal with live operational data, which can be processed either in real time or in batch, and used to facilitate communication between two or more applications, events, or other external APIs. OIC includes dozens of pre-built adapters that make it easy for your integrations to connect to a wide variety of applications or databases and other external systems, which allows you to bring data and applications together across both Oracle and third-party cloud applications, as well as applications hosted on premises. So developers access the integrations feature components from the design menu as shown here, or they can create a new project to organize the building, deploying, and monitoring of one or more related integrations. However, instead of starting from scratch, they can also take advantage of pre-assembled integration solutions known as pre-built integrations. A recipe or accelerator contains all the resources required for a specific integration scenario, and there is a huge collection of these in the integration store. Oracle integration is available in two editions, Standard and Enterprise. Now, either edition gives you the power to integrate your SaaS and on-premise applications using integrations, as well as the embedded file server. Developers can also create custom web or mobile applications using Visual Builder. However, the Enterprise edition provides additional capabilities, including enterprise adapters, as well as the B2B feature. This edition also provides process automation, allowing you to create human-centric business workflows. And that brings us to the end of this overview lesson on OIC. However, among the huge number of upcoming video lessons and demos in this course, we have a lot more to learn about OIC and integrations. Thanks for watching. Welcome back. In this lesson, we'll overview OIC's integrations feature. But before we explore the various components and use cases, now is a good time to review some terminology, specifically with words that have more than just one meaning, such as instance and integration. First of all, there is Oracle Cloud's Platform as a Service, which is called Oracle Integration Cloud, or OIC. And as we discussed in the previous lesson, while OIC includes a number of different components and capabilities, we explicitly identify 5 distinct features or products: File Server, B2B, Process Automation, Visual Builder, and the Integrations feature. which of course is the main scope of this certification training learning path. As we'll explore further in just a bit, this huge feature or product contains a number of components and capabilities which allow for the creation of integrations. However, before someone can start using any of those features, to include integrations, an OIC environment needs to be provisioned, which is also referred to as an OIC instance. Within the scope of an OCI region identified within a compartment, this single OIC instance provides the design time and runtime managed infrastructure that allows you to create Visual Builder applications, process applications, and of course, one or more integrations. Essentially, an integration is a service that you define and configure and then deploy within your OIC instance. And finally, after an integration is activated, it can then be triggered numerous times, perhaps even invoked by multiple concurrent clients. Once that happens, each time it is triggered, a new integration instance is spawned, which runs separately and is identified uniquely with its metadata persisted so it can be tracked later on. So with those definitions better understood, let's dive into this integrations feature overview. In the OIC console, this feature is always exposed. You just click on Design to access all of the individual components, starting with the key component, integrations. As we now understand, an integration is the service you create and deploy to handle a particular integration use case, or perhaps a service used to facilitate some other business requirement, or to provide a layer of abstraction to other services or applications. Essentially, integrations are the main component of the OIC integrations feature, and there are many more lessons later on where we'll learn how to design and build these services. However, creating integrations require other components, starting with adapters. There are over 80 of these pre-installed in your OIC environment. These include Oracle Cloud SaaS applications, third-party cloud SaaS applications, on-premises enterprise apps, social and productivity applications, and other generic technology adapters for databases, FTP and file servers, REST, and SOAP. This graphic illustrates the various categories and icons representing 55 of these adapters. Essentially, you'll be leveraging one or more of these when designing your integrations, which is handled with the configuration of connections. A connection is the component you'll define based on one of the adapters, which will include connectivity and security properties. In addition, you'll leverage that adapter's configuration wizard when configuring the connection for a particular use case within your integration. Some connections, however, will require a component called a connectivity agent. This will be necessary if the external service or application is located in a private network or on premises, or in a private cloud network. Once deployed, these components interact with Oracle Integration Cloud to facilitate that connectivity. To further simplify data mapping within integrations, a lookup associates values used by one application for a specific field with the values used by other applications for a similar field. These are commonly referred to as domain value maps. Well, this capability enables you to map values across various vocabularies or systems. For example, you could create a lookup that maps country codes, city codes, currency codes, or any other type of common data between different systems. Once defined, these lookups work much like a database table, except that the runtime lookup function pulls the data values directly from internal memory. In addition to a host of built-in XSLT functions you can use to assist with your data transformations, OIC also allows you to create one or more custom functions written in JavaScript and then register them as a JavaScript library. Once libraries are added to your OIC environment, you can leverage these new custom functions within the data mapper tool inside your integration, just as you would those built-in functions. While most of the time your integrations will be triggered by an external application or invoked explicitly by a client, another option is to create a local integration service that is triggered with an event published by another integration. An event is defined with a unique name and includes a JSON object, which now can be used for event subscriptions and also published from any other integration. These internal OIC events support a publish-subscribe pattern for the decoupling of certain integrations. And finally, you can group one or more integrations into a package, which greatly simplifies those use cases where you need to export and import a group of integrations that are related to one another, because it also contains the integration's dependencies, such as connections, lookups, libraries, and events. And so to wrap up this overview, integrations are the key component of the OIC integrations feature, and while other required or optional components used to complete the implementation of an integration solution are also there. Thanks for watching. As you've now learned, central to Oracle Integration Cloud is the integrations feature. In this lesson, we'll look at the 3 integration pattern options and provide a high-level list of various use case categories. When you start to create a new integration, you'll have the option to choose one of 3 patterns from the Create Integration Panel wizard: application, schedule, or the event pattern. The difference between these 3 involves how the integration will be triggered. To trigger an application integration, you can define a REST or SOAP-based interface that is designed to be called by some client application. From there, your integration can invoke one or more external applications. Or this pattern also provides an option to leverage certain Oracle Fusion application adapters to subscribe to specific business events to trigger the integration. For example, you could ensure that an Oracle Service Cloud application is updated with information based on data sent from an application pattern integration that was triggered with an event subscription to the adapter for the Oracle CX Sales and B2B Cloud service. The schedule pattern allows you to define a time-based schedule to trigger the integration instead of an adapter. For example, you could add an initial invoke to an FTP server to read a trigger file, and then a second call to download the file for further processing downstream. After designing this integration, you simply schedule when and how often to run it. Finally, the event pattern allows you to decouple integration logic by having your integration subscribe to an event. So now your subscribe integration will be triggered when that event is published by some other local OIC integration. You simply define these events in advance in JSON formatted files. For example, you could create an event pattern integration that subscribes to customer-added events published by other integrations. Once this event is received, the integration could be responsible for other tasks, such as database updates, notifications, or sending data to other downstream applications. With that understanding of integration triggering patterns, we'll now take a look at some common types of use case scenarios, along with a high-level example of each one. Probably the most common type of use case is application-to-application integrations. For example, consider the need to synchronize sales orders from a third-party SaaS application such as Salesforce with your company's system of record maintained in your Oracle ERP cloud application. By utilizing OIC connectors, you can seamlessly sync the sales orders, ensuring efficient data flow. This not only simplifies the process, but it also ensures that every sales order is accurately reflected in both systems, bridging the gap between sales and financial operations. In the implementation, you determine the data mapping, transformation requirements, and any business logic that needs to be applied during the flow of the integration instance. With OIC, certain business workflows can be further automated. For example, clearly the HR onboarding process is important to a new employee's success. Well, you can automate workflows between applicant tracking systems and onboarding tools so that when an applicant's status changes to hired, the system could automatically initiate the onboarding process. In the implementation, workflow automation might require some additional conditional checks so that only a status change to hired would then initiate the onboarding process in the target system. Next, consider real-time data synchronization use cases, such as ensuring that every product sold is accurately reflected in the inventory by providing synchronization between e-commerce platforms and inventory management systems. If no specific built-in OIC adapters were available, the implementation for the integration might include webhooks or polling mechanisms, depending on the capabilities of the system involved. You'd also need to ensure that error handling logic is included for inventory mismatches or sync failures. Of course, there are many use cases that involve extending the capabilities of existing applications. In this example, as the e-commerce world expands, so does the need for diverse payment options. You could then extend the e-commerce application to integrate even unsupported third-party payment gateways, leveraging OIC's capability for creating custom adapters if pre-built adapter connections aren't available. Legacy systems hold vast amounts of invaluable data, and using OIC, businesses can bridge the gap between vintage mainframes and modern cloud-based mobile applications. If the legacy system doesn't provide standard APIs, once again, we can create custom adapters or use other middleware solutions. OIC can then be used to format and forward the data to the cloud application. Customer support is more than just answering queries. It's about trying to provide a unified experience. OIC enables you to integrate separate systems for email, chat, and phone support, resulting ultimately in a single ticket system that aggregates communication history, ensuring that no customer query goes unnoticed or unresolved. Your implementation would need to ensure data consistency and avoid data duplication. For example, if a ticket raised on email and then later was updated via chat, the unified system should reflect a single ticket with a merged communication history. Transitioning to the cloud doesn't mean leaving your data behind. For example, businesses can migrate data from on-premises customer resource management systems to cloud-based platforms. For the implementation, you'll need to consider data validation, transformation, and deduplication. You can also leverage OIC's batch processing capabilities for large data volumes. And the world of IoT, or Internet of Things, is vast and consistently evolving. So use cases of this type are really continuing to grow. As an example, OIC can be used to integrate machinery IoT devices with central monitoring systems. By handling the high volume of real-time data streaming from these devices, businesses, of course, can gain improved insights into their operations for real-time analytics or alerts. Now, since the actual number of integration use cases is limitless, we'll stop here for now. Suffice it to say that the integrations feature of OIC empowers organizations to connect applications, automate and enhance workflows, synchronize data, and modernize legacy systems or applications. That's it for this lesson. Thanks for watching. Welcome back. When we talk about OIC integrations, we use a lot of different terms. Let's take a look at a few of them. First, when it comes to building an integration, we're creating a service that provides a connection between two or more applications and often moving data between them. In a simple integration that passes data from application A to application B, we represent the source system and the destination or target system. We use the word source to refer to the application the data comes from, and destination to refer to the application that receives the data. These are the endpoints of our integration, whether the applications they represent are on-premise or in the cloud. Between the source and destination endpoints, we take action to transform the incoming data into a format that's compatible with the destination system. That action is called data mapping or just mapping. That would suggest just copying incoming data fields to outgoing data fields, and a lot of times that's exactly what we do. But there's more to mapping than just copying. We can also reformat incoming values to suit the needs of the destination system. We can ignore incoming fields we don't need, and we can also insert other values that the destination system needs that aren't necessarily available in the incoming message. Sometimes we use other terms when we talk about source and destination endpoints. The source is also called a trigger, and the destination is sometimes called an invoke. These terms refer to the roles the endpoints play when the integration runs. It might be useful to think about the source endpoint triggering all of the subsequent actions we've defined in our integration. Likewise, it might be helpful to think about the integration calling or invoking interaction with the destination application. And depending on the design pattern of our integration, we might have other combinations of elements, but we still use the same terms. A larger, more complex integration might interact with multiple applications. These interactions might pass data to an external system, receive data from it, or perhaps both. But in any case, each of the additional interactions is also called an invoke. And for each of those invokes, we're also going to use an additional mapping. As we'll learn later on, there's a lot of other actions we can take between invocations, but we'll save those for later lessons. So in the meantime, you should understand these basic terms: source, destination, endpoint, data mapping, trigger, and invoke, as they'll be used rather extensively throughout our training. Welcome. In this lesson, you'll learn about the predefined roles that govern access to Oracle Integration Cloud. Once the OIC instance has been provisioned, in order for anyone to access that environment, first, identity and access management users will need to be added to that OCI tenancy's identity domain by an OCI security administrator. And once that's done, users will need to be assigned to one or more of these 7 service roles: service viewer, invoker, user, monitor, developer, or administrator, depending on what tasks that they will need to do. Most will need to have some level of access to the OIC Service Console, as well as the OIC REST APIs, but also perhaps the permission to invoke integration instances at runtime that are exposed with SOAP or REST APIs. Let's now break down these roles a bit further. A user with the Service Viewer role can navigate to all integration resource pages, for example, integrations, connections, lookups, and libraries, but only can view those details. They'll also have limited access to read-only APIs. Essentially, the console and REST API permissions go hand in hand. Also, this user cannot navigate to the administrative setting pages in the console, nor invoke any administrative APIs. In addition, their credentials cannot invoke any integrations at runtime. By contrast, the service invoker role user cannot access the OIC console at all, nor can they invoke any of the documented Oracle Integration REST APIs. Instead, their credentials provide the permission to invoke any integration flow that is exposed through SOAP or REST APIs, or to trigger a scheduled integration run. The service user role is similar to the service viewer in that they have view-only access to the OIC console and REST APIs. The difference is that they can also run integrations. So in effect, the service user combines the privileges of both the viewer and the invoker. Interestingly, a user with the service monitor role cannot access or view any design time information. However, they can monitor everything provisioned in an OIC instance from a runtime perspective. So, for example, they can view instances and metrics, find out response times, and track whether instance creation completed successfully or failed. Essentially, they can access all of the observability information available in the monitoring dashboard or via the related REST APIs. In addition, of course, they are also not allowed to invoke any integrations. The purpose of this role is for users with limited knowledge of OIC integration design and implementation, but have a high level of knowledge of monitoring it. Of course, this user role does not grant permissions to change anything. A user with the service developer role can create, delete, edit, and develop any of the resources associated with creating, activating, monitoring, and troubleshooting integrations. And since you need to be able to test, these credentials can also be used for runtime access to invoke integrations as well. However, this user cannot navigate to the administrative settings pages in the console nor invoke any administrative APIs. For those of you that choose to access the on-demand lab environment, this is the role you will be assigned in order to be able to perform all of the hands-on lab exercises. And finally, a user with the service administrator role is essentially a super user who can not only manage and administer everything using the OIC service console or REST APIs, but they also can develop and test integrations themselves since they have full developer access as well. And so to review, users can be assigned to one or more of these predefined roles depending on the tasks they will need to perform in your OIC environment. Normally, you'll need to be assigned to the service developer role if you're going to be creating or editing any integrations in OIC. Welcome. In this video, we'll learn about the benefits of using projects for integrations as opposed to creating standalone integrations and other components such as connections as global resources within the OIC environment. A project provides a single unified workspace for you and your team to design, manage, and monitor integrations. Essentially, working within a project helps you get started quickly because you build all the components that an integration needs within the project. You don't need to click all over the user interface to find the right page, to create a new connection, or a lookup or a JavaScript library. It's all right there within your project, including the ability to monitor your integration instances. And after you've built an integration or two within a project, creating additional integrations is even faster and easier because the connections, JavaScript libraries, and lookups from other existing integrations are already accessible for you. Just grab what you need from the streamlined user interface and continue to build additional solutions. Another feature of projects includes the ability to define project deployments, where you can easily move integrations to other environments, such as testing or production. A project deployment represents a list of one or more specific integration and their versions that must be in the environment you're exporting to, which then makes it easier for release management. Accelerators provide pre-built integrations from Oracle or third-party integrators that you can easily customize. And now that the project feature has been added to OIC, all of the newly developed accelerators will be available from now on to install from the integration store as a project that contains one or more version deployments. And to customize within the project, you simply add an extension group to the flow of the pre-built integration. And finally, with projects, you can restrict the users and groups who are allowed to edit, view, and monitor your integrations using role-based access control. In fact, designing integrations within a project is really the only way to control development time accessed at this fine-grained level. To add a new project into your OIC environment from the main navigation pane, just click to open the projects page and click Add. You can either import an existing project that already contains integrations and all of their assets that were previously exported from another system and saved, or you can create a new empty project. You can use any name, but the project identifier must be unique in this environment. Optionally, you can add some keywords as tags to allow others to help search for your project. Also notice that by default, the project will be private to only you unless you choose to make it public to everyone. However, whether your project starts off as public or private, you can then later modify project sharing options at any time. Just click the Share Edit icon shown here. You can specify the users and groups that can edit, view, or monitor integrations within the project using role-based access control, and even change or add project owners. Once you click the Share button, your project page will be updated to reflect those permissions, as shown here. While project permissions are similar to the OIC service roles, such as service developer or service monitor, project permissions are essentially a layer of permissions on top of those service roles. Therefore, project access is restricted based on a user's OIC service role plus their project permissions. So in this example, even though Samvet has edit permissions in this project, if he only had OIC service monitor permissions, he would only be able to monitor. Likewise, even if OIC learners 1 and 2 were assigned the OIC service developer role, they still could only monitor in this project. Once a project is open, there are 3 sections: design, deploy, and observe. It is here on the design page where you create and access your integrations and their dependent components, connections, lookups, and JavaScript libraries. After you've created various components, you can add more by clicking the corresponding plus icon. Also, you access the top drop-down action menu to manage the components, such as viewing, editing, or activating an integration in this example. On the deploy page, you can create one or more project deployments to further organize certain groupings of your integrations. Think of a project deployment as a snapshot of all the integrations that must be deployed together and should be activated as a group. This way, when you export your project, you can specify the intended deployment version. As an example, consider this project with 5 integrations. 2 of them represent an initial version of a deployment, but there is also a new utility integration along with updates to the other 2 integrations that now represent a second deployment. So, as I mentioned earlier, when you export your project on the design page to be used perhaps in another environment, you can indicate which deployment to export. Additionally, even in your own environment, rather than having to explicitly activate or deactivate each and every integration in the project one at a time, from the design page, you can now activate or reactivate a full project deployment. Over in the Observe section, you have a single workspace to monitor all project scoped components. On this integrations page, you can view the message processing status of your activated integrations, including how many messages have been received and processed, how many successful messages or errors have occurred, and how many messages have been canceled. In addition to information details, when you click on various numbers, if you hover over the integration row, clicking View Statistics shows aggregated instance metrics for that integration. On the Instances page, you can filter and track the status of integration instances. You can also view the activity stream and message payload of an instance you are tracking, and you can also replay integration instances configured as replayable. Clicking on Chart View allows you to see timelines for instances grouped by integration. By default, the scale is shown in minutes, but you can change that. And of course, if any integrations have an errored status, just hover your mouse over the instance row and then click View Details to directly access the activity stream so you can start troubleshooting. On the Future Runs page, you can view a calendar of all runs scheduled to trigger in the future across all schedule pattern integrations within the project whose schedules have started. And finally, on the Audit page, you can view and even download the log of design time actions that have been performed by various users in your project. And so to wrap up, there are a number of features associated with projects. The bottom line is this, that Oracle now recommends that you create your integrations and projects, since this provides a single workspace for designing, managing, and monitoring integrations. Using projects makes it easier to perform release management control and access to your integrations and keep everything more organized. Thanks for watching. Welcome. In this video, I'll provide a brief demonstration on the use of projects within OIC. Think of projects as a folder for all of your related integration artifacts to include the integration flows themselves, as well as any dependent connections, lookups, and libraries. You can organize projects however you wish, typically combining related integrations for specific use cases. So in this example, I've got a project for order processing integrations with 3 integrations, one which has 2 versions, their related connections, a lookup, and a library. I can also create new integration artifacts here within this project. So for example, I'll create a new scheduled orchestration. I'll name it AA scheduled and click Create. Now here in the design canvas, I'll just add a simple logger activity. And for this demo, I'll just log the start time. Now, of course, we'll also need to add a business identifier. So in this case, again, I'll just use the start time. And now you will see I'm brought back to my project view, and here's my new integration. So as a reminder, all of the artifacts that I create here are only visible within this project, which is a convenient way of shielding your work from others. Let's go now and activate this integration. We'll select the audit tracing level and click Activate. All of this is done on the design page. Let's now explore the deploy page. Notice that I've already created 2 deployments. As you can see, neither of them include integrations, but let's go in and edit a deployment here. I'll add the NetSuite Create Customer integration, also the Order Finance check and the Order Legal check. And for the Process New Order integration, I have 2 versions. I'll choose version 1 since the latest version is still work in progress. So now with this deployment, I can activate it or deactivate the deployment, which of course results in all of the integrations being activated or deactivated. Or I could export the artifacts in the deployment and import them into another OIC environment. Before we look at the Observe page, let's first go back here to execute some integration instances. I'll be using my new scheduled integration here, and I'll run a few jobs. Let's launch, let's say, 4 of them. I'll also execute one of the app-driven integrations, which will be process new order. This brings up the REST client, and I'll just use the default payload, which is order number 1. We'll send that, and let's execute another one. We can now take a look at the Observe page. Here we see all of the integration instances, and this is, of course, a project-specific view. I could also drill in down to monitor a specific instance from here. Over here is the donut graphic, 100% succeeded, but you can also see the other statuses: errored, aborted, in progress, scheduled jobs that have been queued, paused, blocked, and resubmitted. So again, let's review. A project provides to me a private slice of this OIC environment, and within the project I can design my integration flows and have access to all of the dependent artifacts that I require, which can all be created from here in line. Deployments allow me to group integrations for activation. So for example, I can have version 1 and version 2. And then with the Observe tab, I can get a project-specific view of OIC monitoring. That's it for this demo. Thanks for watching. Welcome. In this lesson, we'll take a high-level look at the basic workflow for creating, deploying, and testing an integration using a specific example for illustration. Let's get started. While there are many tasks and activities involved depending on the use case, I've distilled this development workflow into 5 high-level steps. First, before I start to create a new integration, I need to have an idea for what my use case will be. Then if I don't already have a project, I need to create one. Then based on the use case, I'll create the necessary connections. For this example, my use case is to allow REST API clients to retrieve specific information about accounts into Oracle ERP Cloud based on a provided party ID. I'll need an Invoke connection to Oracle ERP and a REST trigger connection to be used as the interface for clients. I'll now demonstrate creating the project and creating those 2 connections. Within the OIC console, underneath Home, I click on Projects, and we click Add to add a new project. I'll simply create it with the name Getting Started. Now inside of that project page, let's go ahead and click to add a new connection. We'll search for the ERP Cloud Adapter, and I'll give it a simple name and indicate the role in this case will be for an Invoke. For its properties, it needs the ERP Cloud host, and of course I'll need credentials to connect to it. We test that connection, and now the connection is saved. Let's close that connection and create another one. This time when we click the plus sign, I'll search for REST for that REST adapter, give it a simple name, and in this case the role is a trigger role. For this demo, I'm going to change the security to basic authentication. We'll test it, save the connection, and close it. Now it's time to actually create the integration. For this use case, since I've decided to provide a synchronous message exchange pattern for my clients, I'll be creating an application pattern integration. So let's do that now. Under Integrations, I click Add, then click Create, choose the application pattern, and then provide a meaningful name, Get ERP Account Info, and click Create. This brings me to the design canvas. The third high-level step is to configure the required connections. Since this is an application pattern, in addition to configuring the Invoke connection, I must first configure the trigger. In the REST adapter configuration wizard, I'll call this endpoint getInfo, then provide a meaningful description of the purpose and functionality of this trigger connection. I'll now create a URI which includes a template parameter for this HTTP GET and check the box to configure the response. With nothing more to configure for the request, I click Continue, and then select JSON as the response format, where I am pasting this simple design of an object that will be returning these 4 fields of data to our client. I now review a summary of our endpoint and click Finish. Now to configure our ERP Invoke connection. In the adapter wizard, I'll call it Get Account, and once again add a description. This Get Account use case will leverage the first option. The wizard allows me to search for business objects where I select Account, then locate and choose the appropriate operation, Get Account. On the summary page, I click Finish, and we're done. It's now time to map the data. I'll first specify a business identifier. Then, for this use case, I'll need to map the data used to invoke the ERP cloud, as well as the data to be returned to the client. For the business identifier, I click up here to open the configuration pane. Then for this integration, I'll choose the requested account party ID that was sent in as a template parameter. Next, I click Edit to map the data for the Get Account Invoke. In the map editor, I drag and drop that template parameter over to the required input into the ERP cloud request. Click Validate, then close the mapper, where now the map icon shows color since we've implemented the mapping. Now to edit the response mapping. In this case, all of the data I need can be located in the Get Account response from ERP Cloud within the result object. First, the organization name, the owner name, the name of the primary contact, and the primary contact's email address. Once again, I click Validate, then close the mapper. And we're all done, so I'll click to save this integration implementation. With our integration completed, since we'll be testing and potentially troubleshooting, I'll activate it using the debug tracing level, then use the REST test client built into OIC. And so to deploy, I click the drop-down menu next to the integration, click Activate, and here's where I select the debug tracing level, then click the Activate button. It takes just a few seconds until I notice that the integration status is now active. Now to test, from the menu I click Run, which in this case opens an OIC REST test client. I'll paste in a valid account party ID, click the Run button, and in a moment I can now see the returned response below. Now, over on the right pane, the activity stream is shown where I can drill down into the details of this instance. For example, I can expand the response from ERP Cloud to see all of the other data contained within that returned account business object. Finally, clicking over here on the Project Observe tab, the Integrations page provides a summary of the instances that have run, of course, just one so far. Then on the Instances page, in addition to the summary donut chart, I can locate instances by their primary business identifier, allowing me once again to troubleshoot into the activity stream. So to review, while every integration scenario will be unique based on the use case, you now have a general idea as to the basic workflow for developing new integrations from scratch. Thanks for watching. Welcome now to Module 2, Adapters and Connections. Here you'll learn more about the capabilities of these pre-built OIC adapters and learn how to create and define specific adapter connection resources to be used in integrations. You'll also learn how OIC can connect to external systems and applications located on premises or in private cloud networks. And once you complete these videos, don't forget to take the Module 2 skill check. Keep going strong. Welcome to this overview lesson for the Adapters and Connections module. In this video, you'll learn more about the OIC adapter and connection resources and the role they serve in creating integrations. But first, let's revisit integrations. In this case, showing a synchronous application pattern integration flow. Recall that you must define and configure one trigger role connection designed to serve as an interface for clients or to subscribe to some business event or message. In this example, it is a REST adapter interface, which will eventually return a synchronous response to the client via that trigger role connection. Then you add one or more invoke role connections that will make a call to some external service or application. In this example, we have an Oracle ERP Cloud Adapter connection. Next, if you recall, we implement data mapping where needed. In this example, mapping data for the ERP Cloud Invoke, then mapping data for the REST adapter response. So clearly, the key to any integration implementation is how we define and configure those connections. Well, at the heart of every connection resource that you define is the underlying OIC adapter. Adapters simplify and accelerate integration with SaaS and on-premise applications, as well as a variety of other external systems and services. So then, what does the adapter provide? Well, at design time, each adapter has its own configuration wizard that displays in the integration design canvas when you are configuring the connection, either as a trigger or an invoke. Technically, for most types of adapters, a temporary physical connection is established at design time with the external system. This allows for the automatic discovery of application assets such as business objects, services, and events, or in the case of databases, the schemas, tables, and stored procedures. And then later at runtime, OIC establishes a unique physical connection between your integration instance and the external application using that adapter, abstracting you from the complexities of transports and protocols. Other runtime features include session management and both standard and custom error handling capabilities. All adapters provide this UI, which drives a configuration workflow. For invoke connections, it will show the use case options, such as operations that can be invoked on the target system. For those adapters that can be used in the trigger role, you'll see options for how the interface can be configured, or for some applications, the ability to subscribe to a business event. For SaaS applications, the development experience is simplified and streamlined by providing a graphical business object catalog that enables you to natively browse, search, and select one or more business objects of interest without necessarily needing to understand the technical details. And for applications that have their own native query language, for example, Salesforce or Oracle Service Cloud, the Adapter Wizard provides that support as well. Oracle Integration provides an always growing library of specific adapters for both on-premises and cloud applications and databases and enterprise messaging systems, as well as common technology adapters such as FTP, REST, and SOAP. To see the list of all the current built-in adapters, and there are now over 80 of them, and to access an adapter's specific documentation, you'll want to bookmark this main page for OIC adapters in the Help Center. So let's review. Every connection is based on an adapter, and there are two types of connections: trigger role connections, which define the source either as an interface or to receive an event, which will initiate the integration instance, and invoke role connections, which are used to call external target applications or services. That's it for this lesson. Thanks for watching. Welcome back. Now that you have a better understanding of OIC adapters, in this and subsequent lessons, I'll show you how connection resources are created. However, before we begin, let's revisit the difference between creating a connection resource versus configuring a connection within an integration to support a specific use case. Once you have created or defined a connection based on a specific type of adapter, it can then be used by multiple integrations to satisfy a wide variety of use cases. In fact, most of the time, it is the configuring of a connection that will comprise the bulk of your integration implementation work, leveraging the adapter configuration wizard when you add the connection to the integration. In almost all circumstances, creating a connection resource involves associating it with a specific external application, service, or system to which OIC will be communicating with at runtime. While most of the time you only need to create one connection for each external application or service, which can then be used in multiple integration configurations, however, there are circumstances where you should create more than one connection resource for accessing the same system, depending on the intended use cases. Sometimes by design, the connection is created at the project scope, so if it is not marked as global, other developers and other projects will need to create their own connections. Another common case is when different credentials need to be used. For example, to access a database, you might create a connection using user credentials that have read-only access to a certain schema. But then another connection can be created to leverage different database user credentials that have both read and write permissions. Likewise, many SaaS applications are set up to restrict access permission based on assigned user roles. You may have use cases that require a particular role to perform certain operations in the app, while other scenarios require a connection associated with a user with different access permissions. So here's the workflow for creating a connection resource. Step 1 is to select the appropriate OIC adapter, which involves ensuring the prerequisites have been met. Next, in the UI, provide basic information to include the role in which the connection will be used for configuration in the integration. You'll then be presented with options for defining the connection properties as well as defining security properties. Both of these will be specific to the options associated with that particular type of adapter. Finally, you test the connection, validating the connection and security properties. We'll start with the selection of an adapter. The biggest part of the adapter selection process is to determine if all prerequisites have been completed. This is where it's critical that you review the online documentation. The layout is very similar for every adapter, as shown here in this example for the NetSuite adapter. Early on, you'll find general prerequisites as well as specific requirements for certain security policies, along with other information related to creating a new connection. And depending on the adapter, these tasks will likely include discovering the endpoint URL of the application, creating or obtaining the appropriate credentials, perhaps updating role access permissions within the target application. Some adapters require setting up a confidential client application in the OCI tenancy for the OIC instance, and for some external applications, their SSL certificate will need to be uploaded into OIC. In addition, for those applications or systems that are located in your on-premises data center or for services located in a private cloud network, an OIC connectivity agent will need to be downloaded and installed. Of course, depending on the task, it will obviously require someone with the appropriate privileges, such as an administrator for the target system or application, also an OCI administrator, and someone assigned to the service administrator role for your OIC instance. Now that you've selected the adapter, the UI will present the Create Connection page, where you'll provide a meaningful name, which will then automatically generate a unique identifier, but you can change that if you wish. And optionally, provide a description for this connection resource. But most importantly, you must indicate how this connection can be used in integrations. If the adapter supports both trigger and invoke roles, you can choose both if the intent is to use it for more than one integration in both roles. Otherwise, choose just trigger or just invoked based on the intended use case. Also, note, since some adapters only support the invoke role, that will be your only option. Now it's time to fill in those connection properties and choose a security policy and fill in those property values as well. At this point in the workflow, what is shown on the connection resource edit page will depend on the specific adapter. However, since there are just too many adapters to cover the specific options and details for each one regarding those connection and security properties, I'll stop here. But I will continue on in our next few lessons to look at some examples across each of these general categories. See you then, and thanks for watching. Welcome back. Let's pick up where we left off in the previous lessons, creating connections, with part 1 of connection and security properties. Now that you've selected the adapter and addressed any prerequisites, provided a unique name, and determined the role for the connection, you'll be on the page where you must now define connection and security properties. As promised, we're going to look at several examples across these various categories of adapters, starting with Oracle Fusion Cloud applications, regardless of which one, ERP Cloud, HCM Cloud, or the CX Sales and B2B Service Cloud. These adapters support the configuration of connections in either the invoke or trigger role. The connection property is simply the host name URL for your application instance, and for security, you indicate the desired policy. One option is to use OAuth authorization code credentials, assuming someone has completed those prerequisites defined in the adapter documentation, or simply provide a valid username and password. Incidentally, you'll use this option later on if you choose to do the hands-on lab exercises for this course. And for those ERP and HCM cloud connections that will also need to upload files directly to Oracle Web Center content, commonly known as UCM or Universal Content Management, there is also the option to upload the public and private keys required for PGP encryption support. In addition to those Oracle Fusion Cloud apps, there are adapters for a host of other Oracle Cloud applications, along with these Oracle on-premise apps. Suffice it to say that each of these will present their own security options, as well as requirements for connection property details. Let's now shift to third-party SaaS applications, starting with the Salesforce Customer Resource Management Platform. This adapter supports the configuration of connections in either the invoke or trigger role, and as a reminder, you will need to verify that all required prerequisite tasks have been performed. There are a number of them, depending on how you intend to use this connection resource. You'll first select the application instance type, production, sandbox, or government, then enter which API version your instance uses. Under optional properties, a custom domain name can be provided, which is actually required when you are using Salesforce Government Cloud. Then below, you select one of these security policies, providing an authorized Salesforce application username and password, or assuming that OAuth three-legged prerequisites have been completed in Salesforce, provide the client ID and secret for the authorization code credentials policy. Or select this to add the identity of a resource owner in addition to the OAuth client authorization. For this example, we'll look to define a connection using the ServiceNow adapter, which can also be used in either the invoke or trigger role. The connection property just needs the instance name URL that is received once someone has purchased a ServiceNow subscription. Then for security, similar to Salesforce, you can provide either a username password for basic authentication, or assuming the necessary prerequisite tasks are complete, use the authorization code or resource owner password credential policies. The next example is the cloud-based e-commerce application known as Shopify. In addition to invoke role use cases, this adapter also supports trigger role connections so integrations can perform various types of actions against events received from certain Shopify modules. The connection properties include the Shopify hostname, the appropriate Shopify API version, and under optional properties, you can add a comma-separated list of related Shopify connection IDs, which is actually required for trigger role connections so that a single integration can connect to any number of Shopify stores. In addition to basic authentication security policy requiring a valid username and password, you can use either the Shopify access token policy, which requires only an admin API access token, or the Shopify security policy, which in addition to a username password requires a shared secret that was obtained from the prerequisite tasks. And of course, there are many others, but you now get the general idea of how the adapter's Create Connection page presents the connection and security policy options uniquely for each application. And now it's time to look at defining connections to database systems, and we'll start with Oracle's most advanced databases, Autonomous Transaction Processing, and Autonomous Data Warehouse. As with all Oracle databases, one of the key prerequisites is for a database administrator to have downloaded the Client Credentials wallet, which contains all the connection information needed for that database instance. The JDBC over SSL security policy is easy to configure as you just upload that wallet and provide the wallet password. Then indicate the credentials of the database user you wish to use for this connection resource, which will then provide access based on that user's permissions. The JDBC with OCI signature security policy also requires the wallet along with database user credentials. However, the policy requires additional information about OCI object storage along with the credentials needed to access the object storage service in a particular OCI region and compartment. This policy is required if you want to use this connection in an integration that will be using the bulk data import operation directly, which means it isn't using a connectivity agent for access. And while this JDBC basic authentication security policy doesn't require the wallet to be uploaded, you will be able to ascertain the connection properties from the tnsnames.aura file located within that wallet to complete this configuration. Of course, as with the other policies, you'll need to provide credentials for a database user. As to other Oracle databases, such as Oracle Database Cloud Service, Exadata Database Cloud Service, or even an on-premises Oracle database, defining the connection can use the Oracle Wallet Security Policy, where you upload the wallet containing all the connection information, or use the username password token policy, which will require you to obtain that connection information from the tnsnames.aura file. In addition, for on-premises Oracle databases, you will need to associate access with an appropriate connectivity agent. Let's now take a look at a third-party database example, Microsoft SQL Server. This adapter allows you to create a connection to either a SQL Server instance running in your on-premises data center, or you can connect to an Azure SQL database in the cloud. Here there is only the username password token policy, where you provide the credentials of an authorized SQL Service user, and of course you'll obtain the connection information from the SQL Server administrator. For the access, the only option is to associate the connection with a connectivity agent, either deployed in your on-premises data center or deployed in a cloud network that has access to the Azure instance. And of course, there are other database systems, both in the cloud and on premises, that are supported by these OIC adapters. Once again, the connection details and security policy options are specified accordingly in the adapter documentation. All right, we'll wrap up our video recording here, but I'll return in part 2 to continue with more adapter examples. Thanks for watching. Welcome back to part 2 of connection and security properties. In the last video, I concluded with some database examples. Moving now to messaging systems. We'll start with the OCI streaming service, since it is easily available to you as long as you or someone with the appropriate permissions provision a stream in your OCI tenancy. You'll need to obtain the URL for the Stream Pool Bootstrap server, which includes the appropriate OCI region. There is just one security policy. SASL stands for Simple Authentication and Security Layer. The username is a combination of the tenancy name, the OCI username that has permissions to the stream, and the OCID of the stream pool separated by forward slashes, as shown here. The password is actually an OCI authentication token that was generated for that user. And optionally, you can upload a JKS file created when you generate a trust store from the root certificate using the key tool utility. Detailed information for all of this is, once again, provided in the adapter documentation. Finally, if you intend to use this connection to consume new messages as a trigger into an integration, you'll need to associate it with an installed connectivity agent. Since a Kafka cluster can consist of more than one Bootstrap server, you'll provide the host and port for each of those Kafka brokers. And as you can see, the requirements for security is similar to OCI streaming, but only if you choose the SASL plain over SSL security policy. Naturally, the structure for the SASL username will be defined by the target system. What's different here is that since the external Kafka messaging system you wish to connect to could be anywhere and have different security requirements, you have these other options to choose from, to include no security policy. And just like OCI streaming, trigger connections will need to be associated with a connectivity agent. To connect to an Azure Event Grid messaging system, the prerequisite section of the adapter documentation shows how to find your subscription ID, API version, and how to create a resource group. You'll then register an application in the Azure portal and obtain the client ID, secret, and tenant ID. And for trigger role connections, you'll need to add a shared secret value that you obtain from Azure, then click the Provide Consent button to register the grant for OIC to authorize the client. As to access type, you'll need to use a connectivity agent only if that Azure Event Grid is in a private network. Otherwise, the public gateway is fine. And while there are other messaging systems supported, defining these adapter connections will be very similar to the 3 examples we just saw. Let's now look at some examples for social and productivity adapters. First, Eventbrite, a popular cloud application used by event organizers. When defining this connection, you'll notice that only the Invoke role is supported, which makes sense. And as a reminder, check those prerequisites mentioned in the documentation. In this case, you'll need to ensure that an Eventbrite application management account has been created, as well as an application key. Also, an OIC service administrator will need to upload the trusted Eventbrite public certificate into your OIC environment. Now, for security, there are these 2 policies to choose from. This generic OAuth policy only requires the security token, which is displayed on the application management page in Eventbrite, while this custom policy requires both the client ID, which is the application key, along with the secret, which is that same security token. Another example is to create a connection using the Google Calendar adapter, which of course is also used only in the Invoke role. There is only this one security policy, but of course we need to review those prerequisites. In this case, you need to ensure that an account and a Google project has been created. Then within the library section, the Calendar API has been enabled. Then OAuth client credentials need to be created, which is where you get the client ID and secret. And for the scope, you indicate either full access or read-only. Finally, an OIC service administrator will need to upload the GeoTrust Global CA certificate so the adapter can connect securely. Defining a connection using the Slack adapter is very similar to Google Calendar in that there is only one custom security policy, but again, there are specific prerequisites. Someone needs to sign up for a Slack developer account, then create an OAuth application. From there, Slack automatically generates a client ID and client secret, which you'll need to provide here. Also, 1 or more OAuth authorization scopes must be added for that Slack application as shown here, and these correspond to the operations supported by the Slack adapter. And here's where you'll explicitly choose which ones will be needed for your connection. Of course, you may need to review the documentation on the slack.com website for details about these scopes. And in addition to those 3 examples, there are several other adapters, each providing the appropriate documentation for defining connectivity and available security policy options. Generic technology adapters include the REST adapter, which can be used in the Invoke role to access an external web service, or in the trigger role to define an interface for an integration which can be called by a REST client. In a similar manner, the SOAP adapter can be used in the Invoke role to call a SOAP web service, or in the trigger role to define an interface for an integration based on a WSDL, which can then be called by a SOAP client. The FTP adapter is used only in the Invoke role, as it can upload or download files from an SFTP or FTP server. And finally, the file adapter, which is always configured in conjunction with an OIC connectivity agent. When used in the Invoke role, it can read or write files to an on-premises file system, or when used in the trigger role, the connectivity agent will poll for files to be delivered to the integration. As to defining and configuring connections with these technology adapters, since they are used in so many integration solution use cases, I'll be covering each of these in more detail in other lessons. So now, returning to our workflow. Once you have defined all of the required connection and security properties, it's time to test. In fact, until you have performed a successful test, your connection resource will continue to remain in a draft status and won't be available to use in integrations. Now, testing is easy. At the top of the page, next to the Save button, you click Test. This can take a few seconds or perhaps even a minute or two, depending on the type of adapter and external system. Now, if something is wrong, an error message will pop out, similar to this one. Oftentimes the issue is with invalid credentials or perhaps incorrect connection information. Now, after you've resolved the issue, just click Test again. And once the test is successful, the connection resource will now be in the configured status. You save it, and now it can be used in your integrations. So to wrap up, regardless of which type of adapter you're going to be using to define your connection resource, it's important that you ensure that all prerequisite tasks have been handled by those individuals with the appropriate permissions, and that you explore the online documentation for that particular adapter to learn more details about all the various connectivity and security properties that need to be defined. That's it for this lesson. Thanks for watching. Welcome. In this lesson, we'll look at the options you have for defining connections using the generic SOAP technology adapter. Let's get started. First, as with most connections, there are two high-level use cases. You can create a new integration and design an interface based on a WSDL for integration clients by defining a SOAP adapter connection in the trigger role. Or you may need to access an external SOAP-based web service from your integration. If so, you need to define a SOAP adapter connection to designate that service in the Invoke role. In either case, SOAP adapter connections are limited to only HTTP-based SOAP, so no other SOAP transport protocols are supported. We'll start with what is likely to be your more common use case, the need to call some external web service. The Invoke role connection will send a SOAP payload to the external SOAP endpoint, then any response received becomes available within your integration for further processing. Here are some adapter capabilities and limits. For invokes, the adapter will ensure that an outgoing structured payload based on an XML schema does not exceed the size limit, which is currently 100 megabytes, or when using an on-premises connectivity agent, 50 megabytes. As to sending binary or non-binary content as an MTOM attachment, that limit is now 1 gigabyte. The same supported limits are enforced for content structured or non-structured when returned as a response from the invoked web service. Support is also provided for any other header property values that may be required or expected as part of the request message, or that may be returned in the response, whether they be HTTP or SOAP, standard or custom headers. For security, in addition to typical SSL over HTTP invocations, if the external service also requires a client certificate, the adapter can support that two-way SSL handshake. As to security policies, the adapter connection can be configured to support whatever is required by the external service, a username password sent in the HTTP header or in the SOAP header, or providing client credentials or authorization code credentials using OAuth. Also, if the service has no security requirement, you can indicate that no security policy will be used. The adapter connection will also support whatever message exchange patterns are indicated by the external service's WSDL, including synchronous request response, one-way request, or asynchronous request with callback support using the WS addressing SOAP header. Another feature is the ability to support the dynamic discovery of SOAP endpoints. Now, this is useful for scenarios in which the endpoint invoked by the SOAP adapter must be dynamically configured within the integration flow based on runtime logic. So once you've provided a name for the connection and selected the invoke role, the only required connection property is to provide the URL to the external service's WSDL, or you can upload the WSDL if you have a copy of the file. In the security section, you choose the security policy that corresponds with the requirements of that service. For the OAuth client policy, provide the access token along with the client credentials. And for the OAuth authorization code policy, in addition to those property values, you'll also provide the authorization code and scope. In both scenarios, since the adapter's default behavior is to send those client credentials in the SOAP header, you'll only need to use the optional security section if the service's requirements are to send those credentials in either the SOAP body or in an HTTP header. Finally, you'll need to indicate how the OIC adapter will be accessing the web service. In most cases, the web service will be publicly available on the internet, so you'll use the default public gateway. However, if the service is running in a private cloud network, you can connect directly, but only if your OIC service administrator has set that location as a private endpoint for your OIC instance. Otherwise, the only other way to access a private service, either in the cloud or on premises, is via an installed connectivity agent. In this case, you'd select that option, then indicate which agent group will be used. And that wraps up part 1 of our lesson. In part 2, we'll look at the trigger role use case. See you in the next video. Welcome back. Let's continue now with part 2 of defining SOAP adapter connections. As you recall, we have 2 types of use cases for SOAP adapter connections, and since we've already covered the invoke role in part 1, let's now switch gears to the other use case. And in all fairness, this one is not that common anymore, since most of the time when you're looking to expose an integration as a service, you're likely going to choose a REST adapter trigger rather than a SOAP trigger. However, there are still times when this may be your business requirement, so let's explore this use case. When the trigger role is selected, you're essentially looking to define an interface for SOAP clients, and the capabilities of the adapter are very similar to those I articulated when it is used in the invoke role. The payload limits for incoming requests and the returned response is the same. The only difference is an MTOM attachment cannot be accepted in the request, but only as a response. You can also process any header property values that were sent by the client or that you wish to send back to the client in the response. Likewise, since you can choose any valid WSDL file to define the interface, all 3 SOAP message exchange patterns can be supported. As for security, one difference for a trigger interface is that it can only be configured as an HTTPS protocol-based endpoint. You can also choose to enforce two-way SSL, which will require an administrator to ensure valid client certificates are uploaded into the OIC environment. And for security policies, in addition to HTTP or SOAP header-based username password options, there are a variety of additional OAuth 2.0 grant types. And the other difference is that you can choose to instead accept a SAML token from the client to access the integration via the trigger configuration. So then once you've provided a name for the connection and selected the trigger role, in this scenario, you need to upload an abstract WSDL that you or someone else has already designed to describe this interface. Now, if you're not familiar with SOAP, an abstract WSDL document describes what the service does, but not how to contact it. It defines the operations provided by the web service, as well as the input, output, and fault messages used by each operation to communicate with the web service and their format. Much later, after an integration that is using this trigger connection has been activated, a concrete WSDL will be generated by OIC, which you can distribute to clients as it will contain the same information along with the communication protocol to use, which will be HTTP, and the URL that must be used to contact the web service. So essentially, most of the work for creating a SOAP adapter trigger connection will be to design and create the file using a WSDL editor such as XML Spy or the extension available in Oracle JDeveloper. Also, in secure web services transactions, a timestamp can be inserted into a WS security header to define the lifetime of the message in which it is placed. By default, the adapter will process this header, but if yes is selected here, no timestamp is required to be sent by the client. In the security section, you'll need to decide how clients will be required to provide their credentials. With the username password token policy, clients must send a username and password as part of the WSEE SOAP header, while the basic authentication policy requires clients to send the username password as HTTP headers. SAML, of course, expects a valid SAML token from the client. And finally, the OAuth 2.0 policy. OIC supports several OAuth grant types, and each of them will require different setup tasks to be handled by an OCI administrator, all of which are spelled out in the adapter documentation. Now, we won't detail all those tasks here in this lesson, but for now, let's review those supported grant options. The authorization code grant type is used by web and mobile applications and differs from most of the other grant types by first requiring the application to launch a browser to begin the integration. The resource owner password credentials grant type is only suitable for cases where the resource owner has a trust relationship with the OAuth client, and since the credentials can be used directly as an authorization grant to obtain an access token. However, Oracle does not recommend you use this grant due to several risks that you can read about in the documentation. Probably the most important one is that OIC has already announced that support for this grant type is now in a deprecated state. Okay, so the client credentials grant uses an OAuth flow where the client first authenticates with the authorization server and requests an access token from the token endpoint. This grant is typically used by clients to obtain an access token outside of the context of a user. For example, to access resources about themselves rather than to access a user's resources. And finally, the preferred and recommended grant type is to enable JSON Web Token or JOT user assertion. Here, the user assertion is used directly as an authorization grant to obtain an access token. The client details are provided either as an authentication header in the request or as a client assertion. The user can either represent a person or a service integration account created for identifying a specific calling application. Oracle recommends the use of this grant type for applications that must programmatically start the integration without any user intervention. And so to wrap up, in this two-part lesson, we covered the two general use cases for creating connections with a SOAP adapter in the trigger role to serve as a WSDL interface for SOAP clients to an OIC integration, or in the Invoke role, used to identify and access an external web service. That's it for this lesson. Thanks for watching. Welcome. In this lesson, we'll look at the options you have for defining connections using the generic REST technology adapter. Let's get started. First, as with most connections, there are two high-level use cases. You can create a new integration and expose it as a REST API by defining a REST adapter connection in the trigger role. Or you may need to access an external RESTful web service from your integration. If so, you need to define a REST adapter connection to designate that service in the Invoke role. We'll start with the Invoke role use case, where you can define a REST adapter connection to consume any external REST API. Here are some adapter capabilities and limits. For invokes, the adapter will ensure that responses containing attachments do not exceed 1 GB. These can be multi-part mixed or form data or application octet stream. For structured data, which is any content type header containing JSON, XML, HTML, or YAML, the limit for both requests and responses is 100 megabytes or 50 megabytes when using a connectivity agent. As to receiving an unstructured response payload, multi-part form data, or binary octet stream, that limit is also 1 gigabyte. When configuring the connection in the integration flow, you indicate the relative resource URI and a HTTP method, either get, put, post, delete, or patch. Support is available for template parameters as well as one or more optional query parameters. And you'll have the opportunity to define any structured request or response payloads. There, you can use a sample JSON file of up to 100 kilobytes to specify the data type of the request or the response. Or you can create a data definition from an XML document if it is less than 3 megabytes. Support is also provided for any header property value that may be required or expected as part of the request message, or that may be returned in the response, both standard or custom headers. To configure manually, you just provide the URL for the REST API endpoint, or you can define the connection to any REST API that is described using an open API document. At design time, the REST adapter can automatically discover and present all of the available resources and operations present in that document for configurations, to include operation-specific request and response message types. For security, in addition to typical SSL over HTTP invocations, if the external service also requires a client certificate, the adapter can support the two-way SSL handshake. As to security policies, the adapter connection can be configured to support whatever is required by the external service, anything from no credentials or just basic authentication to a variety of OAuth client policies, an Amazon Web Services signature policy, an OCI signature, or support for the resource principal session token for invoking OCI services. This connection also allows you to dynamically change the endpoint configuration from within the integration flow, which is useful if the endpoint is not known at design time, but can be determined at runtime. To define the connection, once you have indicated the invoke role next on the connection page, you can either select to provide the base URL for the web service endpoint, or if the service provides an open API description document, you can indicate that URL. Either way, it is recommended that you do not select a value for transport layer security, since OIC will automatically use the latest TLS version for SSL communication. And if the service requires two-way SSL, you enable this option by selecting yes, then enter the key alias name from the key store file that was specified by the administrator when importing the identity certificate. As to selecting a security policy, you need to select one that corresponds to one of the security options that are supported by the web service provider after reviewing their documentation. So, for example, if they support basic HTTP authentication, you could choose this and just provide a username password. Or if the service requires no authentication, just select no security policy. However, most use cases will likely involve selecting one of these OAuth grant types, again, depending on the requirements of that external service. Suffice it to say that each of these will present required and optional security fields that you'll need to fill in, And you should consult the OIC adapter documentation to explore those property details. Here's an example showing the UI for the OAuth custom three-legged flow security policy. For use cases where you need to invoke an OCI REST API, you can create an API signing key using OpenSSL to pass as a specific credential using this OCI signature policy. Or another option is to use the OCI service invocation policy by using a resource principal session token and creating a dynamic group in OCI to identify your OIC instance as a trusted user. In the case of Amazon Web Service APIs, you specify AWS security credentials and other required fields such as the AWS region using this security policy. And for many other third-party web services that use paid subscriptions, this basic API key-based authentication policy can be used. To summarize, selecting the appropriate security policy and defining security properties will require you to consult both the documentation for that external web service as well as reviewing the OIC REST adapter documentation. Finally, you'll need to indicate how the OIC adapter will be accessing the web service. In most cases, the web service will be publicly available on the internet, so you'll use the default public gateway. However, if the service is running in a private cloud network, you can connect directly, but again, only if your OIC service administrator has set that location as a private endpoint for your OIC instance. Otherwise, the only other way to access a private service, either in the cloud or on premises, is via an installed connectivity agent. In this case, you'd select that option, then indicate which agent group will be used. Let's pivot now quickly to the trigger role use case. Defining a REST trigger connection is quick and easy since there are no connection properties, nor are there any security properties. You only need to decide how clients will be required to authenticate when accessing the integration by selecting a security policy, basic HTTP username and password authentication, OAuth 2 grant types, or support for both. The reason it is this simple is that designing the actual REST API interface will be handled later on when you are configuring this connection as a trigger for a specific integration. There, you will leverage the adapter configuration wizard to assist you with that design implementation. However, regardless of which policy you select, as always, there are other related prerequisites to be considered, all of which are explained thoroughly in the adapter documentation. To facilitate client access, if you do select OAuth 2, you'll need to ensure that an administrator has specified and configured support for the various OAuth 2 grant types in the Oracle Identity Cloud Service application associated with this OIC instance. And for either policy, one or more users will need to be added to the OCI Identity and Access Management Service and assigned to the OIC Service User role. This could represent an actual business user, or it could represent a service integration account used by an external client application. And so to wrap up, we covered the two general use cases for creating connections with the REST adapter in the trigger role to serve as a REST API interface for clients to access an OIC integration, or in the invoke role used to identify and access an external web service. That's it for this lesson. Thanks for watching.